Good day, students. Today, we are going to be solving questions on Physics 0625, May June 2023, Paper 2, Variance 2. I welcome you to your favorite YouTube channel, Physics for Everybody. Do not forget, from the 2023 curriculum, we use the value 9.8 for acceleration due to gravity or the gravitational field strength on the surface of the Earth. So we are going to be solving all these questions. So I believe you have this question paper. If you don't have this question paper, you can download it from the description of this video. So in order not to waste much time, we go straight to the question we have to solve. But let me just mention that when we get to topic that involve detailed explanation like this, then we'll be using our PhET simulation to illustrate that process, okay? And then you see how current will be made to flow and what happens when the circuit is simulated. So that's all we're doing today. Let's go straight to question number one. Number one, forces of 3 Newton and 4 Newton act at right angles as shown. What is the resultant force? You know, when you have two forces acting at right angle, the angle between them is 90 degrees. So to get the resultant, we just use them according to Pythagoras theorem. This formula a squared plus b squared will give us the resultant of these two forces. So we square each of the forces and then we find the square root of the answer we get when we square each of these forces. So let's go. Let's take the first force as the 3 Newton. That will be 3 squared plus 4 squared. Let me fix this. So we have 3 squared plus 4 squared. And if you take 3 squared plus 4 squared, what are you going to get? So you get 9 plus 16, because 3 squared is 9, 4 squared is 16. 9 plus 16 gives you 25, and square root of 25 gives you 5. So the resultant of this force and this force will be a force in the direction that is in between each of these directions. Hence, the resultant will be a 5 Newton force in this direction. That's how you get the resultant of two forces. So what direction is this? Okay, 5 Newton along xz, no, is along this way. 5 Newton along oy. So C is the correct answer to question number 1. So we pick option C. Question number 2 says, a light bulb is held at rest at the top of a tall cliff. It is released and falls through the air, eventually reaching its terminal velocity, which will describe the behavior of the ball as it descends. So when it reaches terminal velocity, what does that mean? That means it is traveling at a constant velocity and it is not accelerating anymore, but it's traveling at a constant velocity. So let's see the initial acceleration of the ball, 0. Then final acceleration of the ball, 0. No. When you release an object, initial acceleration will be the acceleration due to gravity, whose value is 9.8 meters per second squared. So the initial acceleration is not 0. But after the object falls for some time, okay, after falling for some time, then it will have approached terminal velocity. So its acceleration will now be 0. Okay, it only travel downwards. This is the object, this is not 0. This is the object, this is the ball that's falling. Good. So its initial acceleration was acceleration due to gravity, but after falling for some time, because it comes in contact with air molecules that are in the air molecules have introduced a force that acts in the opposite direction to the direction in which it falls. So drag is that force that opposes the falling of the object. Drag opposes this acceleration. So after some time, it attains a terminal velocity, okay? So it will be accelerating downwards, drag will be opposing acceleration. So acceleration begins to reduce till the acceleration becomes 0. Then it falls downward with a constant velocity known as the terminal velocity. So initial acceleration is g, correct? Final acceleration is 0. So C is the only one that gives us the correct answer to that. So we pick option C. Question number 3. The graph represents the motion of a car. How far has the car moved between 0 seconds and 5 seconds? Between 0 seconds and 5 seconds, the time here is 5 seconds. And How far refers to distance. In order to get distance from a speed-time graph, just find the area, this area bounded by this curve. You get the total distance traveled. Or you use the formula final velocity plus initial velocity, okay? Or you say initial velocity plus final velocity divided by 2, multiply all of this by t. Any of these two you do will give you the correct answer. Okay, initial velocity is 0, final velocity is 10, and the time taken is 5. So if you use this formula, you get the correct answer. Let me use the other method, which is to calculate this area. What's the area of this shape? This is a triangle. And what's the formula for area of a triangle? Half base multiplied by the height. So I will do half multiplied by, what's the base? The base is 5. 5. What's the height? The height from here to here is 10. Half multiplied by 5 times 10. Half multiplied by 5 is 2.5. 2.5 multiplied by 10 gives me 25 meters. Okay. If you solve the same question using this formula, U initial velocity 0, V final velocity 10, time taken 5. If you solve this question using this formula, you definitely get 25 as the correct answer. Okay, so you can try it out on your own. Pause this video and try it out. Question number 4. Which statement about mass or weight is not correct? Mass can be compared using a balance. Perfect. Mass is a force. No, it is weight that is the force, and weight is defined as a force on a body due to gravity. That's why weight is mass times gravity. Yeah, weight is a force, so mass is not a force. So this is the one that is not correct. So you shade option B as the option that is not correct. Number 5. A sphere P made of steel has a weight of 10 Newton on Earth. Another sphere Q, also made of steel, has a weight of 10 Newton on Mars. It has the same weight both on Earth and Mars. Okay, there are two different spheres. One sphere is called P, okay? The other sphere is called Q, and each of them weigh 10 Newton. Okay, let's continue. Now, let's see. The gravitational field strength on the Earth is greater than the gravitational field strength on Mars. Which statement is correct? You know, weight is equal to mass times gravity, okay? Weight is equal to mass multiplied by gravity, okay? And that's what gave us 10 here, okay? The same thing with this one. The weight here is mass times gravity, mass multiplied by gravity. If the gravitational field strength on the Earth is greater than gravitational field strength on the Mars, and multiplying these two must give you 10. So you know we gravitational field strength on the Earth is approximately 10, right? So it's very likely the mass here is 1. Now, since we were told that gravitational field strength on the Mars is less than that on Earth, let's assume gravitational field strength on the Mars is you can just pick a value like 5, or you pick a value like 3.7. Okay, so let's just assume 5. If gravitational field strength on the mass is 5, and multiply these two must give you 10 Newton. Okay, multiply these two must give you 10. If this one is 5, then we know already that the mass here must be 2. Okay, so that simply means the mass that you are getting its weight as 10 Newton on the moon will be a 2 kilogram mass. While the mass that you are getting, yeah, we were told that gravitational field strength on the Mars, rather, this is Mars, this is Earth. So we were told that the gravitational field strength on Mars is less than gravitational field strength on Earth. That simply means the mass that you are weighing on Earth will be smaller than the mass you are weighing on Moon. So let's see. The mass of sphere P is the same as mass of sphere Q. No, they don't have the same thing. The mass of sphere P is less than the mass of sphere Q. Should it be this? Yes, the mass of sphere P is 1. Okay, based on our values. Okay, the values we just assigned. You know, we assigned 10 for gravity on the Earth, and we assigned 5 for gravity on the Mars. So you can see that if we consider G on Earth to be higher than G on the Mars, then the mass of the object you are considering on Earth will be smaller than the mass of the object you are considering on the Moon, which is what B tells us. The mass of sphere P is less than the mass of sphere Q. That makes B the correct answer. So we go straight to question number 6. Which two quantities, question number 6 says, which two quantities must be known to determine the density of a material? What's the formula for density? Density is defined as the mass per unit volume. So in order to get the density of an object, you must know the mass, you must know its volume. Let's see mass and volume. That's option B. Option B is the correct answer to question number 6. We go straight to question number 7. A truck is towing a car along a straight horizontal road at a constant speed. This truck is towing this car. Okay, let's see. The rope breaks. So if this rope suddenly breaks, what do you think will happen to the truck? It will definitely accelerate forward. Yeah, so imagine yourself pulling an object. You're pulling an object with a rope and suddenly that rope cuts. What happened? Your hand moves forward. Okay, yeah, if you're pulling an object with a rope and the rope suddenly cuts, immediately the rope cuts, your hand moves forward very fast. So that means the car will definitely accelerate forward. Okay. Yeah. So let's see. Which role gives the direction of the initial acceleration of the truck after the rope breaks and the reason for the acceleration? Why would it accelerate? Let's see. Direction of acceleration to the left? No, it should be to the right. Left? No. Right. Good. This is correct. This is also correct. To the right. Let's see the reason. The driving force is greater than the resistance, is greater than the resistive forces on the truck. Of course, the driving force is greater than the resistive force. That's why the object will accelerate. That's why the truck will accelerate. Let's see this one. The driving force is smaller than the resistive force. No. You see, the driving force is greater than the resisting force. That's why it will accelerate. Question 8. Uniform beam is pivoted at the center and two identical masses, X and Y, are placed so that the beam balances. A smaller mass is then added at the position shown. A smaller mass is added here. How can the masses be positioned so that the beam balances again? So initially it was balanced, right? And then when you introduce another mass here, what happens? This side will have greater moment, okay, than this side. So in order to balance it, is either you shift this one to the center, okay, in order to reduce the moment contributed by this one, or you just bring this one closer to the center in order to reduce the anti-clockwise moment, okay, or you drive this one to the right in order to increase the clockwise moment. Yeah, because introducing this object here will make the anti-clockwise moment to be bigger than the clockwise moment. Okay, yeah, so if it was balanced initially, introducing these objects will increase the anticlockwise moment. So anticlockwise moment is now bigger than clockwise moment. So what will you do to make the anticlockwise moment smaller or to make the clockwise moment bigger? Let's check. Move X away from the pivot. If you move X away from the pivot, what will happen? This is the pivot. If you move X away from the pivot, what will happen? It will increase anticlockwise moment and it will make it more unstable, no? Move X towards the pivot. If you move X towards the pivot, then you'll be reducing the anticlockwise moment, okay? You'll be reducing the anticlockwise moment, okay? So if you reduce anticlockwise moment enough by moving X to the right by enough distance, okay, then the object becomes balanced. So B is the correct answer to this question. So we move straight to the next question, question number 9. A resultant force of 2 Newton acts on an object of mass 3 kg for 6 seconds. What is the change in velocity of the object? You know, from the formula, impulse equals to change in momentum. Okay. What's the formula for impulse? Force times time. And what's formula for change in momentum? That's mass multiplied by change in velocity. Okay. Yeah. So what is the change in velocity? So change in velocity, yeah. So mass times change in velocity, that's the formula for change in momentum. To get change in velocity, we divide both sides by the mass. Yeah, that simply tells us that the change in velocity will be, when the when the mass cancels out the mass, you have change in velocity equals to force times time divided by mass. So you do that here, That should be force. What's the force? 2 Newton. So the change in velocity should be 2 multiplied by the force is 2 Newton. The time is 6 seconds. 2 times 6 divided by the mass. What's the mass? The mass is 3 kilograms. 2 times 6 is 12. 12 divided by 3 gives us 4. That's 4 meters per second. C. That makes option C the correct answer. Question 10. The diagram shows the energy stored for a mobile cell. For a mobile cell. For a mobile cell phone, yeah, cell phone. And how the energy is transferred between energy stores. What describes how chemical energy is transferred? Okay, so chemical energy in the battery will be transferred and it will be converted to internal energy through heating, okay, and kinetic energy, that's sound, okay, yeah. So heating, it will generate heat, of course. Heat will be produced, which is the internal energy, and it will produce sound. But in order to produce sound and produce heat, in what form will the chemical energy be transmitted? It will be transmitted in form of electrical energy. So chemical energy in the battery will flow as electrical energy. So do not forget, batteries don't store electrical energy, they store chemical energy. Yes, the energy stored in the battery is chemical energy. You can send electrical energy to a battery, but it will be stored in the battery as chemical energy. So yeah, while the chemical energy will be coming out as electrical energy and it will be converted to internal energy and kinetic energy, which is sound energy. So what describes how chemical energy is transferred? That's electrical work done. Okay, the flow of um, electrical currents, yeah. That's what describes it. So question 10 is A. Let's go to question 11. A wind turbine is 30% efficient and has an output of 2.5 megawatts of electrical power. What is the power input to the turbine? What's the formula for efficiency? Efficiency, no, let me not use the symbol for efficiency. Efficiency is the useful output power divided by the total input power multiplied by 100%. Now, if the efficiency is 30%, um, eliminating this percentage here, we can express the efficiency in decimal form. Just divide 30% by 100, you get 0.3. So efficiency is 0.3. That should give us, what's the useful output? It has an output of 2.5 megawatts. 2.5 megawatts, convert it to what? 2.5 mega means a million. So to convert 2.5 megawatts to what? It will be 2.5 multiplied by 1 million. That will be 2500000. Let me see if it's complete. 1, 2, 3, 4, 5, 6. Yeah. Divided by total input energy, because total input energy is the unknown. Okay, so this formula is what I just expressed here. Okay, I just eliminated this 100% because I was expressing this as a decimal, okay, as a fraction of 1. Okay, yeah, as a portion of the one whole of the total energy. You know, maximum efficiency a machine can have is one whole, which is 100%. So to get total input energy, just introduce a denominator of 1 and cross multiply. So what you are doing is total input multiplied by 0.3. That will be 0.3 times of the total input energy should give us 2500000. So to get the total input energy, just divide both sides by 0.3. Divide this by 0.3. Let's see, 2.5 million divided by 0.3. 2.5 million divided by 0.3. That gives us 83333333. Let me see if I missed anything. Okay, I've not missed anything. Let's see. So what answer do we have here? 1, 2, 3, 4, 5, 6. That's 8.3 megawatts. Okay, Yeah, if you divide this value by 1000, you get 8.3. You get it in megawatts because the option are in megawatts. Okay, so what we have is 8.3 megawatts. That makes option B the correct answer to this question. Okay, so let me erase all of this so that you can see what you've done so far clearly. We go straight to question number 12. Which two physical quantities must be used to calculate the power developed by a student running up a flight of steps? Okay, how do we calculate power? What is the formula for power? Power is equal to work done divided by time taken. Or you say power is equal to energy divided by time. So what you need is work divided by time, or energy and time. So which two physical quantities must be used to calculate power? Number one, is it force and height? No. Is it force and time? No. Work done and vertical height? No. Work done and time taken? Yes, work done and time taken only. That makes option D the correct answer to question 12. 13. The density of seawater is 1030 kg per meter cube. Gravitational field strength on Earth is 9.8 Newton per kilogram. Atmospheric pressure is 1001 Pascal. At which depth is at which depth in sea water is the total pressure due to atmosphere and water equal to 513,000 Pascal? What does this mean? Now, let us consider the surface of the earth. On the surface of the earth, on the surface of the earth, we have air, okay, and that air creates atmospheric pressure. Now, this question has told us that atmospheric pressure on the surface of the earth is 101,000. 101,000. That's atmospheric pressure. That's atmospheric pressure on the surface of the earth. Now, as for the water bodies, okay, so let's use this color to represent water. Now, we have water, yeah, and molecules of water are here. So when you go inside the water too, there is also some pressure due to water molecule, and the formula for that pressure is density times gravity times height. So you were told that at what height would we have the total pressure due to atmosphere plus that due to the water to be equal to 513,000 Pascal. So if you add them together, you should get 513,000 Pascal. So that's what the question requires of us, to get what height that this will be the total. Okay, do not forget that we have some pressure due to air molecule present in the atmosphere. Okay, yeah, so this is the sand. Okay, yeah, so we use color blue to represent the sand and we use color red to represent the water. So the pressure at the surface of the on the surface of the water is already 101,000. Okay, now let's assume there was no pressure on the surface of the water. There will be pressure due to this water, and the formula will be density times gravity times height. So in total, at this point, this pressure is due to both the water and the atmospheric pressure above the water. So both of them will add up together to create this thing. Okay, so if you are calculating a mathematical model for this, we say this total pressure, the pressure total will be equals to pressure due to the atmosphere plus pressure due to the water here, which is density times gravity times height. This is the formula we'll be using to solve this question. Okay, the pressure total pressure will be pressure due to the atmosphere plus pressure due to the water. Okay, what's total pressure? We have it at 513,000. 513,000 equals to, what's pressure due to the atmosphere? 101,000. 101,000 plus density. What's density of water? We have density of water of the seawater as 1030 multiplied by acceleration due to gravity is 9.8 as given here, multiplied by what? The height. What's the height? The height was not given. So this height here is the unknown. So when we solve this mathematical expression, you get the correct answer. So I will open a blank white sheet and solve this question there. So I've opened this blank page in order to solve this question. I'm going to solve it here. So this exact mathematical expression and is what I have here. So I just want to solve it here and bring back my answer. So in order to solve this, I'll move this on to the left hand side. So I have 513,000 minus 101,000 will be equal to, now I multiply these two, 1030 multiplied by 9.8. 1030 multiplied by 9.8. 1030 multiplied by 9.8. Yeah. 1030 multiplied by 9.8 gives us 10,094. 10,094. So we have 10,094 H. So if I take the difference between these two, I will get 412,000 is equal to 10,094 H. In order to get H, you divide both sides by 10,094. 10,094. These two will cancel out. So you have the height as 412,000 divided by 10,094. So 412,000 divided by 10,094. 412,000 divided by 10,094 gave us 376. Let me check the option. No. Something must have been missed somewhere. Let me check what we missed. Okay, this is 10,094, not 1,094. It's 10,094. And I mistakenly wrote 1,094. So let me complete it as 10,094. So this is 10,094. Let me put all those zeros there. So I'm to divide this by 10,094. So I have 412,000 divided by 10,094. And this gave me 40.81. Okay, so I'm expecting total significant place. That's 40.8. So 40.8 is the correct answer, and that makes option A the correct answer to question 13. Question 14. Four students describe the phrase absolute zero during a lesson on the particle model. Which student is correct? This is the lowest possible temperature. Of course, absolute zero is the lowest possible temperature. Particles in a solid start vibrating. That is when you give them a kinetic energy. So absolute zero, the particle do not vibrate. They stop vibrating. Particles do not have any weight. Well, weight has nothing to do with temperature. Particles have the least gravitational potential energy. Gravitational potential energy has nothing to do with absolute zero. Four students are asked to state and explain the relative magnitude of thermal expansion of solids and gases. Solids and gases. Which student is correct? The first student says gases expand more than solids because because the molecules in a gas are in random motion. No, that's not the reason. Gases expand more than solids because the attractive forces between molecules are much weaker in gases. True. That's why gas molecules are far apart normally, while the molecules of solid are very close together because of that strong intermolecular force of attraction between adjacent molecules. But in the case of gases, we have very weak force of attraction between adjacent molecules. That's why they are always far apart. So that makes B, yes. Gas expand more than solid because of the attractive force between the molecules are much weaker. That makes B the correct answer to question number 15. Question 16. Four cups A, B, C, and D contain hot coffee. Which cup keeps the coffee warm the longest? Okay, outside the surface. Okay, this is the color. We know that black surfaces are poor transmitters of thermal energy. Okay, as we were saying, dark surfaces are poor transmitters of thermal energy. So if the surface is black, it means it won't give out the heat. So the cup not giving out heat means it is retaining the heat, and it makes the cup warmer for a long period of time. So this black surface will keep the cup warmer. What about here? Covered with lead. Hold on, hold on, hold on. Okay, sorry for that mistake. When it comes to receiving thermal energy, dark surfaces absorb much heat because they take in all the colors of light, and they know they don't give out any color. That's why dark surfaces absorb much heat. They are good absorbers of radiant energy. What about transmitting energy? They are also the best transmitters of thermal energy. Just as they are the best absorber, they are the best transmitter. So if the cup is black, it will give out the heat energy quickly. What about a white surface? White surfaces do not absorb thermal energy because they give out all the colors of visible light. Okay. Also, they also bounce back infrared. They don't want to absorb the infrared. When it comes to transmitting thermal energy, white surfaces also, they do what? They do not transmit thermal energy. It is black surfaces that easily transmit, just as they easily absorb. White surfaces do not easily transmit thermal energy. They are very reluctant to transmit thermal energy. So that's why the white surfaces will keep the coffee warm for a long period of time. Yes, so that is what we have here. So these two would keep the coffee warmer for a long period of time. What about covered with lid? Yeah, when you cover it with lid, it keeps it warmer because this is the coffee, this is the lid. The lid will stop evaporation, so there will be no escape of thermal energy through convection. So that makes option C the correct answer to this question. Let's go straight to question 17. The diagram shows a wave. This is the wave. What are the amplitude and wavelength of the wave? Amplitude is maximum displacement of a wave, of the particles of a wave from the main position. So this is the maximum displacement. Amplitude is 3 centimeter. Then wavelength is the distance between adjacent crests, two successive crests or two successive troughs. So the distance, okay, there's only one trough here. There are two crests here. So the distance between these two crests is 8 centimeters. That makes the wavelength 8. So amplitude is 3, wavelength 8. Amplitude 3, wavelength 8. That makes option B the correct answer to question 17. Let's go to question 18. Optic fibers are used to transmit digital signals using infrared radiation. The average refractive index of the fiber is 1.50. Which rule describes a digital signal and gives the speed of infrared radiation in the fiber? Well, you know the speed of light is 300 millimeter per second, okay? Speed of light is 300 millimeter per second. So the speed of infrared radiation in an optical fiber in the tube is close to that value. I mean, not exact value, but it's very fast, okay, and very close to that value. So look at these values. This is more than the speed of light, so it definitely can be this, okay? It can be either of this, okay? So these two are correct values for the speed of infrared ray in the glass tube, in the optic fiber rather. Then digital signal. What are digital signal? A signal that consists of only two values. Yes, digital signals are either 1 or 0, on or off, true or false. That's what you mean by digital. Okay, that's what you mean when you say digital. So a digital signal consists of only two values. So that makes option A the correct answer. Okay, correct speed, correct response for digital signal. Question 19. Which statement describes monochromatic light? Monochromatic light is light that has only one wavelength, okay, or light of only one frequency. That's what I mean by monochromatic. Light of a single frequency. Option A is the correct answer to question 19. Let's go to question 20. A beam of light consists of yellow and blue light. The beam of light is incident on a glass prism. Which diagram is correct? Okay, during the dispersion of light, of course, when the light goes this way, there will be a refraction downward, another refraction downward again. So this one is not correct. There will be refraction upward. No, refraction is refracted downward and refracted downward again. So this is not correct. Refracted downward and downward again. That's correct. So what will be the first color here? It will be red. Okay, red, orange, yellow, green, blue. So if you have red, orange, yellow, green, blue, indigo, violet. Yeah, indigo, violet. So yellow should come before blue. But here you have blue coming before yellow. That's wrong. Yellow before blue. Correct. That means option D the correct answer. You know these colors of the rainbow. Yeah, the colors of the rainbow. That's what we use to know the color that should be at the top in the dispersion of white light. That makes option D the correct answer to question 20. Let's go straight to question number 21. A radio station broadcasts a signal with a frequency of 87 megahertz. What is the wavelength of this signal? You know, from the wave equation, speed is equal to frequency multiplied by wavelength. If you want to get wavelength, divide both sides by the frequency of the wave. Frequency we cancel out, we have wavelength is equal to speed of light divided by the frequency. What is speed of light? 800 million meter per second. Sorry, 300 million meter per second. That's the speed of light. 300 million meter per second. Okay, 3 times 10 to the power 8. What's the frequency? 89 megahertz. That's 89 times 10 to the power 6. So let's divide 300 million by 89 million. 300 million divided by 89 million. Just 300 divided by 89, you get 3.37. That makes 3.37 the correct answer. Okay, let's look at the values we have here. They are all to two decimal place. So instead of writing 3.37, we just write 3. Hold on. Instead of writing 3.37, we just write 3.2 decimal place, 3.4. So our correct answer should be 3.4. We have 3.4 here. Good. Option B is the correct answer to question 21. 22. A boy shouts and hears the echo from a tall building 2.5 seconds later. The speed of sound in air is 230 meters per second. How far away from the boy is the building? Okay, so when you are dealing with echo, you have a source of sound. Okay, let's assume that the boy is the source of sound. Let this be the boy. I don't want these two diagrams to interfere with each other. That's how we use color black in solving this question. So let's use color black in solving this question. So this is the boy and this is the tall building. So when the boy shouts, what happens? The sound goes, hits the building, okay, and then bounces back to hit the boy. What happens? That means the distance traveled by the sound is twice the distance between the boy and the wall, okay, because the distance traveled will be double of the distance between the boy and the wall. Okay, so when they say how far away from the boy is the building, we use the formula speed velocity equals to distance over time. Why did I write 2D as distance? Because the distance traveled by the wave is twice the normal distance between the boy and the wall. The normal distance between the boy and the wall is represented with D. Okay, and the distance traveled by the wave is 2D. Okay, 1D going, 1D coming. So this is the formula we are using. So to get make D the subject of formula, introduce a denominator of 1 and cross multiply. That means 2D is equal to VT, right? So to get D, divide both sides by 2. It means the distance is equal to VT over 2. That's how VT. So let's try that. What's the speed? 330 meters per second. What's the time? 2.2. Divide this by 2. Okay. So 330 times 2.2 divided by 2. Let's see. 330 times 2.2 divided by 2. That gives us 363. 363. Okay, since all the values are written to two significant figures, you won't write 363, you write it to two significant figures. Okay, 363 to two significant figures, that will be 360. Yeah, that's what I mean by two single figures. Only the first two figures. Others become 0. 360. That makes option C the correct answer to question 22. Do not forget to subscribe to this channel if this video is useful to you and is helping you to understand physics better and is preparing you for your exam. Number 23. The magnetic field of a bar magnet can be represented by magnetic field lines. Which diagram shows two magnetic field lines correctly? You know, magnetic field lines of force, magnetic lines of force, they come out from the North Pole and they enter again through the South Pole. So from this, they are the lines of force coming out from the North Pole and they are entering from the South Pole. That makes this one the correct answer. They are entering through the North Pole, that's wrong. Entering to the North, so that's wrong. Coming out from North, good. Coming out from South, that's wrong. A is the correct answer to question 23. Let me return to my color blue, okay, so that you can easily see my handwriting. A plastic rod is rubbed with dry cloth. The rod becomes the rod becomes positively charged. Okay, so if the rod is positively charged, that means it has lost electrons, right? Yeah, that's why it has a resultant negative charge. Yeah, the uncharged rod has both positive and negative charges. Okay, so if the resulting charge is positive, that means it has lost some negative charges. Yeah, that's why the resulting charge is positive. Okay, good. One, it has gained electrons. No, it has gained neutrons. No, it has lost electrons. C. Option C is the correct answer to question 24. It must have lost electrons for it to gain resultant positive charge. 25. Which statement about electric current in a conductor is correct? In DC circuit, the electric current gradually decreases along the conductor. Not necessary. In a DC circuit, the free electrons flow back and forth. That's an AC circuit. In an AC circuit, the electric current remains exactly the same all the time. No, that's for a DC. In an AC circuit, the flow of charge changes direction continuously. Correct. That's what makes it AC, because the flow of charge is changing direction. Okay. At one half, the one half cycle is going in one direction. Okay, the other half cycle is going in the other direction. Okay, so current continues to go through and fro through the conductor. That's the case of AC. Question 26. A piece of metal wire X with uniform diameter has a resistance R. This is the wire X. The second piece of wire Y is made of the same metal and has uniform diameter. Okay, this is the second wire, has the same uniform diameter. Y has double the cross-sectional area of X. The cross-sectional area of this conductor is twice the cross-sectional area of this conductor. Okay, what else do we have? We also have that Y has double the cross-sectional area of X. Okay, that's stated. And half the length of X. Okay, so if the length of X is 10, it means the length of Y will be 5. It has half the length. What is the resistance of Y? Okay, we have R over 4, R over 2, R over R. Okay, now let's see. What's the formula for resistance? Resistance of a wire is resistivity multiplied by the length divided by area. What does that mean? That simply means the resistance of a wire is directly proportional to the length and inversely proportional to the area. Okay, so what can we bring out from this? This simply tells us that if the length, okay, so as for y has double cross-sectional area. So if the area is becoming double, if you are doubling the area, you want to double the area, and then what are we doing to the length? As for the length, we are halving the length. Okay, the length will be halved. So let me put that here. Half. Okay, so what does this mean to us? Halving the length and doubling the area. If you are halving the length, since resistance is proportional to length, halving the length means you are having the resistance, okay? So I'll just multiply the resistance by half, okay? For you to have the length, you are having the resistance because resistance is directly proportional to length. What about the area? If you are increasing the denominator, okay, since resistance is inversely proportional to area, that means if area is increasing, resistance will be decreasing. So if area is doubling, it means resistance will be halving again. So you are multiplying the resistance by half again, okay? So you are multiplying the resistance by half and half. That means you have 1/4 of the R. That is R over 4. That makes A the correct answer to this question. I hope this is understood. Please, if you don't understand, you have to go back and watch that part of the video again. We are getting close to our simulation. An electric fire is connected to a 240-volt supply and transfers energy at a rate of 1.0 kilowatts. How much charge passes through the fire in 1 hour? We are looking for the quantity of charge. Okay, let's use our whiteboard so that we can solve. What formula for electrical energy? Electrical energy is IVT. And do not forget that power is energy divided by time, right? Power is energy divided by time. That simply means power will be what? IVT, or you say ITV, is the same thing, okay? IVT and ITV, they are the same thing, okay? Do not forget that ITV represents energy, okay? Then we have to divide it by time again. ITV divided by time. Now you have to recall one formula. Recall that the quantity of electric charge is equal to what? IT, where Q represents the quantity of charge. So we can use Q to represent this IT, okay? We are not going to cancel T. We can't say T cancel T, no. Use Q to represent IT in this expression. So the power is equal to what? We don't need this anymore. We don't need this anymore. This is what we need here, okay? Okay, let me not remove it so it won't look. Instead of writing IT here, we write Q. So we have Q multiplied by what? V, voltage, divided by what? Time over T. The question requests for what? The question requests for the charge. So you want to make Q the subject. To make Q the subject, we introduce a denominator of 1 and cross multiply. That simply means QV is equal to power times time. To make Q the subject, divide both sides by V. That simply means the quantity of charge is equal to PT divided by voltage. I hope this is understood. Quantity of charge is power times time divided by voltage. So quantity of charge will be equal to, what's the power here? 1 kilowatt. 1 kilowatt will be 1000 watts. Okay. Q multiplied by time. What's the time here? 1 hour. Convert 1 hour to second. It will be 1 hour multiplied by 60 in order to convert to minutes. Multiplied by another 60 in order to convert to second. Because 60 minutes make 1 hour and 60 seconds make 1 minute. Okay, so 60 seconds make 1 minute, 60 minutes make 1 hour. Yeah, so you understand this is the QT. All of these represent time, okay? This is the Q, okay? Divided by what? Divided by power. Divided by voltage rather, okay? QT over V. Sorry, PT over V. Power, time, voltage. This is the power, 1 kilowatt. This is the time, 1 hour. Divided by voltage. What's the voltage? 240 volts. Now we are going to multiply 1000 by 60 times 60 and we divide our answer by 240. Let's go. 1000 multiplied by 60 multiplied by 60 divided by 240. What answer do we get? 15,000. That means 15,000 coulombs the charge, okay? 15,000 coulombs, okay? So what options do we have? Our options are recorded in standard form. Let's express this in standard form. 1, 2, 3, 4. So when you bring the decimal point here, you have to introduce times 10 to the power 4. So you bring the decimal point here, introduce times 10 to the power 4. This is how you express large values in standard form. So that makes option C the correct answer to question 27. Now, in order to understand question 28, we will have to use our simulation. That's why I built this circuit here. Okay. So you see, this circuit is a perfect representation of what we have. We have the battery up here. The positive terminal is on the left hand side. This is the positive terminal. You can see this is the negative terminal. This is a lamp, another lamp down there, then three switches, 1, 2, 3. And that's what we have here. The battery positive terminal on the left hand side, negative terminal on the right. We have a lamp here. Sorry, we have a lamp here, then three switches, 1, 2, 3. The question says, which switches must be closed so that both lamps light? So if you want this one and this one to come on, then there must be full connection here so that current can flow here. The same current that as current is flowing here, do not forget that current coming here will be split into two. Some goes here, some goes here. So if there's no current flowing here, no current will be able to flow here. So you just have to switch on the three switches so that the current can flow. And that is represented here. Okay, so these are the switches. Okay, these are the switches, they're all open. Okay, so if you close this switch and close this switch, current only flows down here, not here. So if you have to close this third one so that both switches are working. If any of these switches is any of these switches is open, no current will flow. Okay, if you open this one and close this one, no current will flow. Both must be closed. This one also has to be closed. If you open this one, no current will flow here. You have to close all the switches so that current can flow in both through both lamps. Okay, so which switches must be closed so that both lamps light, all of them, S1, S2 and S3? That makes option D the correct answer. Please, if you like what I'm doing here, please subscribe to my channel. Yeah, this channel, YouTube channel, will be 5 years old in a couple of days, and I want to hit 5,000 followers. 5,000 subscribers. The diagram shows a circuit that switches on a lamp when there is a change in environment. Okay, now you have to study this circuit. This is the single cell. This is the cell, and we have a what? This is a temperature dependent resistor. When temperature is high, resistance drops. When temperature is low, resistance increases. This is a resistor. This is a relay. This is a relay. A relay is just like a switch that is powered by a DC current. It could be AC too, though, but judging from the circuit, it is a DC relay because it is connected to a DC. So what do I mean by all I'm saying? Now this is a relay. A relay is being switched on when it receives enough voltage. Now, what happens here? Which change in environment causes the lamp to be switched on? This is a temperature dependent resistor. So when temperature is very low, the resistance here will be low. That simply means the voltage here, voltage drop across this resistance will become higher. Yeah, because all this voltage must be dropped here. So if little voltage is being dropped here, then high voltage will be dropped here. That simply means the voltage here will become high and it switches on the relay. Switching on the relay means this switch becomes closed and current will be able to flow and this lamp or bulb comes on. When temperature is low, when the temperature is low, the resistance here will be what? High. Okay, that means resistance here will be more than resistance here. That will be the design of this circuit. And the voltage across this light dependent resistor will be higher, while the voltage across this one will be lower according to the voltage divider. Voltage is being divided according to the resistance. So when the resistance here is higher, more voltage will be across this and lower voltage will be here. When the voltage here is low, that low voltage will be seen by the relay and it won't be enough to switch on this circuit. Okay, so this is being controlled by temperature. So which change in environment causes the lamp to be switched on? It is a decrease in temperature. When temperature decreases, resistance here will be low, resistance here will be higher than this, making voltage here high. So it's a decrease in temperature. A decrease in light, no. A decrease in temperature. B. That makes option B the correct answer to question 29. An increase in temperature. Yes, sorry. When temperature is high, resistance here will be low. And as resistance here is low, it means resistance here will be high. That high resistance will be seen by the relay, okay, and it switches it on. So it is a low resistance that makes this thing come on. When resistance is high, yes, when resistance here is low, it makes this one see low voltage. Voltage here will be high. And what will make the resistance of a temperature dependent resistor? What will make its resistance low? High temperature. When temperature is high, the resistance of this material will drop. Okay, so a high temperature will make this resistance drop and will eventually switch on this relay. So we need high temperature. So increase in temperature is the correct answer. Sorry, I have to just cross check with my marking guard here. All right. So question 30. A step down transformer is 100% efficient. A step-down transformer is 100% efficient. It has an input voltage of 240 volts and an output voltage of 60 volts. The current in the primary coil is 0.5 amperes. What is the current in the secondary coil? Since it's 100% efficient, that means the power input must be equal to the power output. What's power input? That's current. Power is equal to IV, right? That is current in the primary cell multiplied by voltage in the primary cell. Okay, must be equal to what's power output? That's current in the secondary cell multiplied by voltage in the secondary cell. So this is the formula we'll be using. Okay. Now, what is the current in the secondary coil? To get the current in the secondary coil, let's just divide both sides by voltage in the secondary coil. Divide this by Vs. Okay, so that simply means current in the secondary cell on the secondary coil will be given by the formula current in the primary, voltage in the primary divided by voltage in the secondary. So this is the formula we're using. So let's substitute. What's the current in the primary? The current in the primary cell is 0.5 amperes. We have 0.5 multiplied by voltage in the primary. The input voltage is 240 volts. That's the input voltage. Voltage in the primary is the um, input voltage. Then the output is the secondary, 60 volts. Okay. So 240 times 0.5 is 120. 120 divided by 60 gives us 2. So our answer will be 2 ampere. That makes option C the correct answer here. Question 31. The diagram shows the pattern of the magnetic field due to current I in the straight wire. So there's a straight wire here and there's current I flowing through this wire. Which is correct? Direction, the direction of field, the relative strength of the field. Magnetic field will be stronger at the middle and weaker at the edges here. And direction of the field, since current is flowing this way, according to the right hand grip rule, okay, the thumb represents the direction of current, okay. This thumb represents the direction of current, then your fingers wrapped around this conductor represent the direction of the magnetic field. So you see magnetic field, they go in this direction, okay, in line with the diagram. That's the direction of Y. Okay, that's correct. Then I represent the direction of the current. Okay, the direction my thumb is pointing at downwards. That's the direction of current. My fingers direction of Y. Okay, so X is the only wrong one there. Which row is correct? Direction of field X, no. Direction of field is Y. Then greater at the center, greater at P, no. P is not the center, Q is the center. So we have Y greater at Q, which is the center, okay, yeah, and it will be weaker at P, which is at the edge. So that makes the correct answer to question number 31. Question 32. Which device is the magnetic in which device is the magnetic effect of a current not used? Okay. Which device does not use electromagnetism? Electromagnet, of course, it uses it. Loudspeaker, yes. Loudspeaker has a magnet with a coil and a coil in it. Potential divider, is it potential divider? Yes. As for the potential divider, you will have voltage, just as I explained concerning the potential divider, and the voltage will be higher when the resistance is high and voltage will be lower when the resistance is low. Okay, this is just a simple illustration of potential divider. Okay, if you just let's assume this was a pure resistance and not a temperature dependent resistor. This could act as a potential divider, and there's no form of coil in this potential divider. Okay, it's only the relay where you have the coil. So potential divider does not use magnetism. Okay, relay, of course, the relay uses magnetic effects of current carrying conductor. Fission and fusion are two types of nuclear process. How does the total mass of the nuclides produced compare with the total mass of the original nuclide or nuclides in this nuclear process? A. Total mass of fusion. Total mass of fusion product compared to the original nuclide. Is it the same, or is it more, or is it less? Total mass of fusion product compared with original nuclide. Is it the same? Is it less? Is it more? As long as energy is being released in the process, it follows from Albert Einstein's law of relativity that says E is equal to mc squared. Okay, the energy release is mc squared. That means mass times speed of light squared. That simply means mass can be converted to energy. Also, energy can be converted to mass or matter. Okay, so from this equation, you see that for energy to be released, some mass will be completely converted to energy. So that shows that at the end, the mass will be reduced because some mass has been converted to energy. But the reduction in mass is always very small, so tiny that sometimes it could be considered negligible. But there is actually some reduction in mass, no matter how negligible, no matter how tiny it is, there will be a reduction in mass. Okay, yeah. So it also follows through that if there is tremendous amount of energy, matter can be produced. I'm sure that can be used to explain the creation of the creation. Let's go. So same, no, less. That makes B the correct answer. Okay. Yeah. Question 34. The table shows the composition of three different nuclei. Okay, we have nucleus X, Y, Z, number of protons for X, 3, number of neutrons for X, 3, Y, number of protons, 3, number of neutrons, 4, Z, number of protons, 4, number of neutrons, 3. Which nuclei are isotopes of the same element? For us to have the same element, they must have the same atomic number, right? Yeah, atomic number is the number of protons. So just which one that has the same the same number of proton. X and Y, they are the ones that have the same number of proton. That means they have the same atomic number, and that's the same atomic number and different mass number, okay, or different nucleon number. That is the concept of isotopy. That means X and Y are isotopes, okay. Z is a different atom entirely and is not an isotope of any of these two. So X and Y are the only isotopes, X and Y only. That makes B the correct answer to question number 34. We go straight to question number 35. Which change occurs in the nucleus of a radioactive atom during beta emission? Yeah, during beta emission, what happens? A neutron, a neutron has a mass of 1 and atomic number of 1, mass of 1. A neutron will be converted to a proton. Proton has mass of 1, charge of 1. Sorry, a neutron has a mass of 1, charge of 0. The charge of a neutron is 0. So this should be 0. Okay, so a neutron will be converted to a proton and what? Electron. Charge of -1, mass of electron is 0. Yeah, so this is what happens during beta decay, okay, when an element emits a beta particle. This is what happens, okay. So a neutron will be converted to a proton and an electron. So this process can also be illustrated using our simulation platform, our PhET interactive simulation. Let me introduce a proton and neutron. So this is hydrogen 2, okay, a deuterium atom, okay, number of proton 1, number of neutron 1. What if it is tritium? Tritium has 2 neutrons and 1 proton, okay. one proton, two neutrons. So this is also an isotope of hydrogen, tritium. And tritium is capable of undergoing a beta decay. During beta decay, what happens? Color gray represents what? Color gray represents neutron. It shows that one neutron will become what? Color orange is what? Proton. One neutron becomes a proton plus what? An electron that would speed off, that will accelerate off. That's what this means, okay? One neutron will convert to a proton. You know, color orange is proton, oh, sorry. This is what I'm talking about, not color green. This is the one that is highlighted that can occur. So one neutron will be converted to a proton plus what? Color purple, that's electron plus an electron. You know, an electron is a beta particle, okay? When an electron is emitted from the nucleus of an atom, that is a beta decay, okay? So let it undergo beta decay. What happens? You see the electron being fired away, and one of the neutrons gets converted to a proton, okay? And helium-3 is formed. Let me reverse the process so you can see it again. So there are two neutrons, okay? Two neutrons, one proton. When it undergoes beta decay, you see the change here. So there are now two protons, one neutron. The electron has escaped. So that illustrates the process, okay? So let's see. A neutron transforms into a proton and an electron. Correct. So A is the correct answer to question 35, yeah? Confirm. 36. A radioactive isotope has a half-life of 8 days. A detector close to a sample of this isotope gives a count rate of 200 counts per minute. Without the source, the background count is 20 counts per minute. What is the count rate due to the source after 8 days? Okay, so initially we have 200 counts per minute, right? And the half-life is 8 days. That means after 8 days, it should reduce from 200. This thing should be halved, right? But take note that we have background radiation of 20 counts. So if initially it's producing 200 counts per minute, by the time we put background radiation into consideration, that means the actual count will be 200 minus 20, which is 180 counts per minute. That's the initial decay rate. Okay, that's the initial rate of decay. Yeah. Now, after 8 days, what happened? 8 days is the half-life. So we have to divide this 180 by 2 to get what we get. We have 90 counts per minute. This will become the rate of decay after 8 days. It will be 90 counts per minute. Okay? Yeah. So that's what we have after 8 days, 90 counts per minute. The question says, what is the count rate due to the source after 8 days? This is the count rate due to the source only after 8 days. We are not to put background radiation into consideration in this case. So this is what is due to the source after 8 days. That makes B the correct answer to question 36. Question 37. Which statement about the solar system is correct? All the planets are rocky. That is not correct. Not all the planets are rocky. So the second option says only the Earth has a moon. That's not correct. Most of the planets in the solar system have moon. Pluto is a dwarf planet. That's correct. Pluto is a dwarf planet, a very small planet. There are many stars. There are many stars in the solar system. Our solar system has only one star, which is the sun. The sun is the only star, the only source of light in the solar system. Though there are billions and trillions of stars in the universe, but in our own solar system, there are only 9 planets and one star. So this is the only correct option. Pluto is a dwarf planet. We go straight to question 38. Comets are bodies which orbit the sun in the solar system. What is the shape of the orbit and how is the sun positioned in the orbit? The shape of the orbit is circular. No, it is elliptical. The position of the sun, is it center of the orbit or not at the center of the orbit? Option D is the correct answer because the shape of the orbit is elliptical and the sun is not at the center of the orbit. That's due to gravity. The contribution of all the planets contribute to the gravitational force. It's not only the sun. If it was only the sun and only one planet, then the shape would be circular. But because there are 9 planets, all the planets they interact. The gravitational pull of each planet interacts. All the planets interact with each other, okay? And they all now interact with the main one, which is gravitational force of the gravitational pull of the sun on each of the planets, okay? That's why it follows an elliptical path, and the sun is not at the center of the elliptical path. We go straight to question 39. Question 39 says, which nuclear reaction produces the release of energy to power a star? Yes, that is exactly what is happening in the sun. We have two smaller nuclei coming together to form a heavier nuclei. And what are those smaller nuclei? Those are hydrogen atoms, okay? Deuterium and tritium coming together to form helium, okay? And then a neutron will be produced as in the process. So which nuclear reaction produces the release of energy to power a star? Nuclear fission. It is nuclear fusion of hydrogen into helium. Two hydrogen isotopes, two hydrogen atoms fuse together to form helium atom. That makes option D the correct answer to question 39. Question 40. What is the definition of Hubble constant? You know, Hubble constant, it's we get it by dividing the speed with which a galaxy is moving away from ours. We divide it by what? We divide it by the distance between that galaxy and our own galaxy. Okay, yeah. So this is the definition of Hubble's constant. So that is what option A tells us. Option A says the ratio of the speed at which a galaxy is receding from the Earth to the distance from the Earth, and that is what we have here. Okay, okay, yeah. So these are from the, I said solar system, yes, but our actual frame of reference is our own planet, the Earth, because we are viewing all of this from the Earth. So the value of change in wavelength, no. Constant used to represent rate of expansion, of course not. Estimated constant equal to the age of the universe, no. Age of the universe, all of that, we get that through um, um, half-life. So and you know that during this process, there will be red shifting, and you must have learnt about red shifting during your physics classes. So that brings us to the end of this past question. Thank you very much for joining me in this. Ensure you subscribe to this channel if this video has helped you, and ensure you keep watching other videos that are being produced on this channel in order to help you to perform very well in other papers and other subjects too. I've started producing videos on chemistry. Ensure you subscribe to this channel and watch all of this video. Thank you very much. Do have a nice day. I wish you the best of all your exams. Goodbye.